Okay, hello everyone. My name is Jamin, and today I will be taking you through the small POC, which is our first entry point into predictive maintenance. The product that we have selected as of now is the Rounds Manager, the Syclo Rounds Manager. Rounds Manager ideally is used for by the employees of a company who are responsible for taking the readings of the machinery and equipment and the utilities they have in their area. And for example, they could do it for equipment, for function, location, etc. Equipments usually have their notifications and maintenance work orders. Notifications are also triggered from rounds manager, where if the readings are not in the acceptable range, plant maintenance notification could be created, which then could be processed by a maintenance person, and if required, work order also could be created. But well, that's not the scope of this demo. The scope of this demo is to identify and bring in a probability of a equipment to be to fail. So, for example, if I as a maintenance a rounds manager go to a particular machine and equipment, I want the intelligence on my hand in my device to understand what is the probability of this equipment to fail as of now, in the sense, in terms of time dimension, as of now when I'm standing right there in the front of the machine. Or then I could also be able to see what is going to happen in next few hours or next few days. uh, this time dimension is always from the last failure of the equipment. So we have a very well-known terminologies in around this dimension is the mean time between failure. So say an equipment has been reported to be broken down via notifications or work orders, etc. For three times in a past history as 3,000, 7,000, and 5,000. So the summation of that is 15,000 and divided by 3 is 5,000. So 5,000 is the mean time between failure, but it did not necessarily be the time when the equipment's probability is the highest, or in the range where we would want to avoid the equipment to be going down. So what we need is, as and when I go in terms of time dimension ahead and ahead, I should be on my hand, I should identify from historical data what is the probability of this machine falling down. And then based on companies policies or equipment's severity or configurations, we could then decide that if a probability is beyond certain limit, there should be an option of creating notification, where we then create a notification to avoid a particular breakdown. So with that as a context set, I would quickly take you through the demo. This is a standards rounds manager application on Windows platform. I'll show you what are the enhancements as and when we reach there. So we select a particular equipment for rounds manager. So I select equipment 1002, and now I could see the points of this equipment. Points are nothing but actual values for which we want to take a measurement. It could be a thermometer or an RPM meter or a pressure gauge set on the device. So it has some points. What I would do is I would go into the equipment details. So equipment, where is it located, is out of box. Points, so what are the measurement points? As I mentioned, measuring temperature could be one of the points against which we do the readings. So obviously we could go here and do the readings. But then what I have done is I have enhanced with another tab called equipment breakdown probability. Breakdown probability now shows me hours since last breakdown, and it shows me the probability of it going down. So 28% probability of it going down as of now at 5,000 hours. Obviously when I increase it keeps increasing, right? So as and when I go ahead, you see that the probability keeps increasing, and when it crosses 30%, 40%, so according to the configuration and the severity of the machine usage, we could decide that beyond a particular probability, I would go ahead and create a notification. So this is the Windows UI that we have shown over here for different devices and different capabilities coming up in the SMP world now. This could also be a chart, an interactive graphical chart, etc. So this is what we want to start into predictive maintenance. The second stage of predictive maintenance is obviously based on the different values collected on the machine. It also could include environmental variables or process variables, and creating a regression out of it to understand which are the main contributors of the breakdown, and then based on those readings that we take, so based on those points that we collect now, we also show what is the probability of the breakdown. So that is stage two, which is more effort consuming, but this is the start point for predictive maintenance. So how does this all fit in together? So what are the components in terms of system landscape in this area? So I'll just quickly try and take you through what happened so far. What we have is we have our mobile application that we just saw. So this is a mobile device. What we then have is the entire equipment data is sitting in our standard ERP box, for example. So all the notification and historical data is in standard SAP ERP. So it has my equipment data, the historical breakdown data. So in Syclo, for example, we have used the enhancement frameworks pretty heavy. Enhancement frameworks are part of SAP where any change that happens, so any change on equipment data, let's say as soon as an equipment uh, history changes. Yeah, so this is my enhancement framework. It's a I'll just encapsulate just to make a point over here. This is my enhancement detection. So this is my enhancement um, framework. Yeah, as soon as it detects that there is an equipment history change, so that there has been new breakdown information coming up, what we do is we collect all that set and then we push it into our in-memory database, the HANA, to utilize the excellent capabilities of this in-memory database. So then we come into HANA. Now, in HANA, we could do a lot of things with existing PAL algorithms as well. So this is my HANA DB. I'll just put it into my HANA uh, table. Sorry. Not only would I put this stuff into my HANA table, but then I would also have on top of it some views which I need to process the algorithm. So once I am into this HANA box, I'll just quickly note it down that we are into HANA. So this is my HANA. Yeah. In my HANA, I have my HANA tables and views. And now what I would do is for this particular algorithm, what we have done is we have gone beyond the PAL algorithms. We wanted a cumulative distribution function. So we have a VBull algorithm which helps us identify the probability density function, which is across the life cycle. It gives a summation of total probability 1. So it just gives us where the spikes of probability are majorly distributed. But we could also use this to cumulatively add on to the graphs, where we could then see on the curve going tending upwards on the bell curve, which are the probability of failure, and then coming downwards is probability of success or non-failure, for example. So vbull by default is not available as of now in PAL. It's available in the R server. HANA can be connected to R server. R is an open source, so HANA can be connected to R server very easily. So we have the connectivity set between R server, and what we do is that from HANA we then from our enhancement framework, when we just put the changes into the DB, after those changes we also run a report, right, which would then call up HANA procedure. So it would then call the HANA procedure, right, and this would mean that from my HANA procedure I expect the intelligent data on CDF. So HANA procedure, and this HANA procedure then calls back the R language procedure, the vbull, part of it which is responsible for cumulative. So I would call, I'll just say as of now over here, PV bull. Alright. And then what it does is that it will then return me the data in terms of the cumulative distribution function. So I get the data, right? This data would be, okay, I'm sorry. Uh, this data would then be pushed from the HANA procedure into the storage of HANA. So if required, this could also be then used from Access engine and have more interactive and intelligent reporting on top of it, which we didn't do. That's just a delta effort that is required. And then this HANA procedure will also then from this program and the procedure, we would then pass the data back to the enhancement framework, and so it will be from both the places. And this cumulative data, then we also store it into a table, into uh, a DB table into ERP, right? So this DB table would have, for example, equipment identifiers. It would have hours since last hours since last breakdown, right? And it would also have the probability of failure. This data is then passed to my mobile part, so I just try and use a different shade to make sure this is the Syclo part. So I use this data and bring it up and preload it into data during the sync. So we have a concept of complex tables. So it is available as a complex table in my Syclo. So I have a complex table of equipment breakdown. So I just say complex. I just use complex table for equipment breakdown, uh, equipment breakdown probability. Okay, so then I have this available in my mobile as of now in Syclo as an offline version, and then I could show it as on the UI with various possibilities of graph and other representation techniques to then see based on hours since the last breakdown what is the current probability, and then I can create notification. So this is more or less the overall picture of what I have tried to organize in this entire POC. In the next session, I would probably take you through the technicality a bit more. Thank you.